Hello everyone, myself Preeti. Today I present a topic Auger electron spectroscopy in which I explain about the what is electron beam techniques, where does the AES signal come from, Auger electron spectroscopy and its Auger process, its nomenclature, energy spectrum diagram, its instrumentation, application and advantages. When an electron beam target to the material sample, then there is a many possibilities. And each possibility give rise to one of the characterized techniques, that is reflection, transmission, absorption and emission. Reflection which is characterized by the scanning electron microscopy, low energy electron diffraction, high energy electron diffraction and voltage current. In the same way, transmission is characterized by the transmission electron microscopy and yields electron energy low spectroscopy. And absorption is characterized by the electron beam induced current, and emission is characterized by the cathodoluminescence, Auger electron spectroscopy and electron microprobe. And in the upcoming slides we discussed about the Auger electron spectroscopy. So where does the signal come from? So here is a sample of solid sample. Here is a solid sample. When an electron beam fall on the solid surface, then there is a small dark portion from where electron get ejected, and that electron is Auger electron. If the energy of incident electron is very high, then there is a possibility of secondary emission of secondary electron, backscattered electron and characteristic X-rays. So these emission of electrons, that is secondary electrons, backscattered electrons and characteristic X-rays, are determined by the technique SAM, that is secondary electron microscopy. So Auger electrons escape from a very shallow surface electrons, and Auger technique samples a depth of typically 0.5 nanometer to 5 nanometer. Auger electron spectroscopy. Auger electron spectroscopy, it is widely used to investigate the composition of surfaces of solids. Firstly, it is discovered in 1923 by Mittner, but lately it is independently discovered by Sir Victor Auger in 1925. It is also used for the study of oxidation of catalysis, chemistry of fractured interfaces and grain boundaries. Here I discuss about what is Auger process. When an incident electron having energy 3 to 5 kilo electron volt, then there is a removal of energy shell electron, which create a vacancy. This inner shell vacancy is filled by the outer shell of the electron. When outermost shell electron fill the vacancy of inner shell electron, that it releases energy. This energy is useful to knock out the third electron, and that third electron is known as Auger electron. How the nomenclature of Auger transition take place? Since there are three levels, 1s, 2s and 2p are involved when Auger transition electron get emitted. That it is. So each shell has its unique notation to represent the Auger transition. That is, for 1s it is represented as K, for 2s L1, for 2p 1 by 2 it's L2 and 2p 3 by 2 it's L3. So from above figure, in which 1s, 2s and 2p 1 by 2 transitions are involved, so Auger transition label as K L1 L2. Three symbols in the transition label corresponds to the three energy levels which involved in the Auger transition. Here is the Auger energy spectrum, which plotted between the signal intensity Ne and the kinetic energy electron volt. This spectrum gives the energy and shape of Auger peaks, which contain the information about the chemical environment. As theoretical predictions and reference data, spectra are often used for the comparison. Auger energy spectrum From the Auger energy spectrum, we also get the chemical information of that element. Here is the two spectra of carbon and aluminium, from which we get the info what type of element it is by knowing the Auger energy spectrum. Here is the differential spectrum. It is a direct spectrum of AES when it is converted into a differential spectrum which is plotted between the differential of electron signal and the electron volt, that is energy, which provide a clear information about the Auger electron spectrum as it gave a sharp peak which is easy to understand. Here is the Auger peaks between beryllium, boron, carbon, nitrogen, oxygen, fluorine and sodium. We only get the information of atomic number is more than lithium, which is one of its disadvantages. We cannot determine the Auger peaks for hydrogen, helium and lithium. Now we discuss a AES instrumentation. It consists UHV environment, an electron gun, electron beam control, electron energy analyzer, which is divided into further subparts, retarding potential analyzer, cylindrical mirror analyzer, which is the most common tool for AES instrumentation. Third one is hemispherical analyzer, at the end electron detector. So why we need a UHV? UHV abbreviate as ultra high vacuum. It is required for the surface analysis for the following reasons: as it removes the absorbed gases from the sample, it eliminates the absorption of contaminant on the sample, to prevent high voltage breakdown, and to increase the mean free path for electrons, ions and photons. Electron gun. In most of the cases, the electron source is thermoionic in nature. But for the highest spatial resolution, the bright field emission gun source may be used, which we discuss in upcoming slide. Here is the image of field emission gun which is used for better resolution. So what type of nature of electron gun is required? The nature of electron gun is used for the AES analysis mainly depend on the following factors. It depends on the speed of analysis, and that speed is required a high beam current. When the current is lower, then it give a high spatial resolution. But when the current is very high, then it provide a speed and it also provide a high sensitivity. But the spatial resolution is not as good as it provide a lower current. It also required a good spatial resolution and the induced beam changes with the sample surface. Electron energy analyzer. The function of electron energy analyzer is to disperse the secondary emitted electron from the sample according to their energies. An analyzer may be either magnetic or electrostatic in nature because electrons are influenced by a magnetic field. It is essential to cancel these fields within an enclosed volume 2 of the analysis, and the stray magnetic field cancel each by using metal shielding. Here is the image of hemispherical electron energy analyzer which is used, but one of the most common analyzer is CMA. CMA stands for cylindrical mirror analyzer. It is one of the most common electron energy detector because of their high transmission efficiency, which leads to better signal to noise ratio. Here is a CMA cylindrical mirror analyzer. As a primary electron beam hit the sample surface, then an Auger electron move outward in all direction, which shown in red, blue and green line. As Auger electron move outward in all direction and some pass through the aperture in inner cylinder. The negative potential which apply on outer cylinder bend the Auger electron back towards the inner cylinder and exit the aperture and reach to the detector. So here is a sample, and that a cylindrical curve is taken by Auger electron and reach to the electron detector. So now electron detector. Now we discuss about the detectors. When electrons pass through analyzer, secondary electrons of particular energy are separated from electrons which are of different energies. So various detectors are used to detect these electrons. This is the electron multiplier. Basically, electron multiplier consists a series of electrodes which is called diodes. At the output end of this electron multiplier, a high positive voltage is applied. When electrons strike the first diode, then it produces secondary electron. This secondary electron then strike to the another diode which produces more secondary electrons. In this way, these electrons strike to the series of these diodes and it produces a cascade of secondary electrons which helps for collecting the data and we get a Auger spectrum. Here is a continuous electron multiplier. Its shape is in like a horn. Its principle is same as discrete diode, but electrons are emitted from continuous inner surface of horn. And this surface of a continuous electron multiplier is made up of lead silicate glass. Here is the application of Auger electron spectroscopy. Auger electron spectroscopy helps to identify the surface composition. It also helps to study the composition which is a function of depth. Auger electron spectroscopy also helps to analyze the sample which are very small in size and also, from which we get a spot size. It also helps to characterize the chemical composition of that sample. Auger electron spectroscopy analyzes the sample feature which are very small as 80 nanometer. So what are the advantages of Auger electron spectroscopy? Auger electron spectroscopy is surface sensitive and this technique is non-destructive technique. Auger electron spectroscopy is used for the element which are heavier than lithium, as Auger electron spectroscopy in which there is a involve of 3 electrons, so that it is not good for hydrogen, helium and lithium, but it is good for elements which are heavier than lithium. Even it is good for the light elements also. From Auger electron spectroscopy, we also get the depth profiling analysis, from which we get information which is a function of depth. From this, we also get the spatial distribution elements. From this, elemental or even a chemical Auger maps analysis in lines and points and areas. From Auger electron spectroscopy, we get elemental and chemical composition analysis by comparing with our standard sample of non-composition. Here is the AES summary. As an beam of electrons strike the sample, then Auger electron is get excited. This Auger electron have energy characteristic of that element which present on the surface. Auger electron reveal the chemical elemental composition and chemistry of the surface. It also provide the chemical bonding of the atom with that surface. It also provide the depth profiling when ions strike on the surface. It also provide a high spatial resolution of the electron beam and surface specificity allow for high resolution microanalysis. At the end, AES, it provides a high lateral resolution, reasonable sensitivity up to 100 ppm. It provides a quantitative analysis without the empirical standards and it also provides the chemical bonding information. Thank you.